Okay, periodic table. Please switch on your camera and keep your book open. Yes, so classification on the basis of atomic weight. Earlier, all the scientists who tried to classify the elements, discovered elements, they tried to do it on the basis of atomic weight. So that was the blunder that they were doing. And so none of them succeeded. All those who were trying to classify the elements on the basis of atomic weights could not succeed, because the mistake that they were doing was they were classifying the elements based on their atomic. The first one who tried to do this was Doberman, because his piece of classification was in a group of 3 called triads. Doberman laws triads, so chemically analogous elements arranged in increasing order of the atomic weight formed well-marked groups of 3 called triads. So he tried to arrange the elements in a group of 3 in such a way that the atomic weight of the middle element was the average of the first and the last one. So let's take an example: lithium, sodium, potassium. So lithium, sodium, and potassium. So lithium atomic weight was 23, potassium 39. So if we check 7 plus 39, that is 46, and half of 46, that is 23, and that is 2. So his basis of classification was that the elements were arranged in a group of 3 in such a way that the atomic weight of the middle element was the average, was the arithmetic mean of the first and the last one. The atomic weight of the middle element was the arithmetic mean of the first and the last one. Okay, so chemically analogous elements arranged in increasing order of their atomic weights formed groups of 3 called triads, in which the atomic weight of the middle element was generally the average or the arithmetic mean of the atomic weight of the first 2, the other 2, that is the first and the last one. But then this theory was rejected. Method was disordered collection of elements. Because of the disordered collection of elements, and the properties of elements grouped into triads were not found to be similar. So method was disordered, not holding true for all the elements, and then the properties of the elements grouped into triads were not found to be similar. So they didn't have the similar properties, and so this was rejected. So who was the first one to try to classify? Who was the first one to classify? What was his name? Ashi, what was the name? Just what we have done. What's that? What's the problem? What's the first one to classify?
Can you please again explain? I didn't understand.
Who is I am asking the name of the scientist. Who is the first one to classify? What's the name of the scientist? Can you read it out? Who is the first one? Where are you? Page 80.
Oh, periodic.
Triads.
Periodic.
Huh? Classification of elements.
Yes, ma'am.
Frobenius triads. Who is the first one? So Dobenier.
Daubernier.
So the first scientist that you are going to study about is Daubernier.
Yes, ma'am.
Okay, and his method of classification is known as Daubernier's triads. His method of classification is known as Daubernier's triads. What is his method of classification known as?
Daubernier triads.
Daubernier triads. Janvi, is this clear?
Yes, ma'am.
Now, Daubernier, he arranged the elements in a group of 3 based on increasing order of atomic weight. He arranged the elements in group of 3, only group of 3. Okay, and the basis of arrangement was increasing order of atomic weight. And how did he do it? What did he do was that he took 3 elements such that the atomic weight of the middlemost element was the arithmetic mean of the first and the last one. So, for example, he made a group of lithium, sodium, potassium. So the atomic weight of lithium is 7, potassium is 39. So 39 plus 7, that is 46 divided by 2, that is 23. So he put sodium in between. So atomic weight of sodium is half of the average of the first one and the last one, that is 7 plus 39. Is this clear? क्या किया उसने? उसने 3 एलिमेंट्स को ग्रुप में डाला. एक ग्रुप में 3 एलिमेंट डाला. कैसे 3 एलिमेंट डाला? Such that the weight of first element and the last element को add करो, उसका आधा करो. Arithmetic mean of the first element and the last element will be the weight of the middle element. ठीक है? And तो उसने ऐसे ग्रुप्स बनाए, पर उसके ग्रुप्स चले नहीं. क्यों नहीं चले? क्योंकि it was not holding true for all the elements. सारे elements को हम ऐसे ग्रुप नहीं कर सकते. And secondly, they were the properties of the elements जिसको ग्रुप किया था, उनकी properties similar नहीं थी. They differed in the properties. So these were the 2 major reasons. And so Daubernier's triads, law of triads, was rejected. Clear? So the first scientist was Daubernier. And his method of classification is known as law of triads. He gave us the law of triads. तो फिर उसके बाद एक दूसरा साइंटिस्ट आया कॉल्ड न्यूलैंड. न्यूलैंड को म्यूजिक बहुत पसंद था. ठीक है, उसको म्यूजिक बहुत पसंद था, तो उसने अपने म्यूजिक के ऊपर से ऑक्टेव्स बनाया. सारे ग म प ध नी सा, तो वैसे इंग्लिश में भी है. तो उसने म्यूजिकल नोट के ऊपर, on the basis of musical note, he tried to arrange the elements. तो उसने series of 8 बनाया. Okay, such that the first and the last one, that is the first and the 8th element, were similar. So elements were arranged again. Blunder क्या था उनका? Again वही था. He also tried to arrange the elements on the basis of atomic weight. So elements will repeat. They have similarity in the properties. Just like sa, re, ga, ma, pa, dha, ni, sa. The first and the last. Okay. First one is sa, last one is sa. So they are having similarity. So in this way, the first element and the last element had similarity in their properties. So on the basis of octaves, he arranged the elements in the increasing order of their atomic weight. But then ये भी गलत हो गया, क्योंकि method showed odd groupings and failed. He couldn't leave spaces for undiscovered elements. And method of classification showed meaning with the light element, lithium and sodium, but failed with heavy elements, metals beyond potassium. So chlorine beyond potassium, he couldn't succeed. So law of octaves be rejected. Okay, तो अभी तक दो साइंटिस्ट ने ट्राई किया, डॉबर्नियर ने ट्राई किया ट्रायड्स बनाने का, लॉ ऑफ ट्रायड्स, उसका नहीं चला. फिर न्यूलैंड आया, न्यूलैंड ने लॉ ऑफ ऑक्टेव्स दिया, in which the first and the eighth element were having similar properties based on the increasing order of atomic weight. वो भी नहीं चला, it couldn't go beyond the metals, beyond potassium, and then he couldn't leave spaces for undiscovered elements. ठीक है, अभी तक समझ में आया?
Yes, ma'am.
Okay. उसके बाद आया मेंडलीव. उसने बोला हटाओ सबको, ये लोग कोई कुछ नहीं कर पा रहे, ट्रायड्स भी कुछ नहीं कर पा रहा, ऑक्टेव्स भी कुछ नहीं कर पा रहा, सबको हटाओ. तो फिर उसने बोला चलो मैं एक लॉन्ग फॉर्म ऑफ पीरियोडिक टेबल दूंगा, मैं लॉन्ग टेबल दूंगा जिसका नाम रखूंगा पीरियोडिक टेबल. नाम उसने बहुत अच्छा रखा, पीरियोडिक टेबल, जो नाम आज भी हम लोग यूज कर रहे हैं, पीरियोडिक टेबल. ओके, सो ये उसका एक प्लस पॉइंट था, उसने एक नाम दिया पीरियोडिक टेबल. और उसने क्या किया, उसने वर्टिकल कॉलम्स बनाए जिसको ग्रुप्स बोलते, और हॉरिजॉन्टल रोज बनाए जिसको कॉलम्स, जिसको पीरियड्स बोलते. तो ये ग्रुप्स और पीरियड्स वी आर यूजिंग टुडे आल्सो. ठीक है, सो ही अरेंज्ड, बट ब्लंडर उसका एक ही था. अगेन and again the scientists were doing the same mistake. Which mistake the scientists were doing?
Arranging them with using the atomic weight.
Correct. एक ही मिस्टेक को रिपीट कर रहे हैं वो लोग बार बार. They are using the atomic weights. So उसने फिर से एक प्रॉपर्टी भी दे दी, पीरियोडिसिटी ऑफ प्रॉपर्टी. उसने बोला कि कुछ इंटरवल के बाद फिर से एलिमेंट्स एक जैसे बिहेव करते हैं. So the phenomenon is called periodicity of the property, and properties which repeat themselves are called periodic property. उसने क्या बोला? This arrangement had elements with similar properties appearing at regular intervals. At regular intervals, if the elements are arranged in the increasing order of their atomic weights, at regular intervals, they show similarity in the properties. And this phenomenon was called periodicity in properties. Periodicity in properties, the same properties are coming again and again after a certain interval. Okay, so उसने physics and उसने एक periodic law दिया, Mendeleev's periodic law. The physical and chemical properties of elements are periodic function of their atomic weights. उसने periodic law दिया. The physical and chemical properties of elements are periodic function of their atomic weights. Okay, तो इसने थोड़ा अच्छा काम किया था, लेकिन सबसे बुरा काम क्या था इसका? एटॉमिक वेट्स. उसने एटॉमिक वेट्स को ही बेसिस माना. सो मेंडलीव्स का कंट्रीब्यूशन मांगते हैं, दे आस्क इन स्कूल. सो व्हाट वर द कंट्रीब्यूशन? नंबर 1, हॉरिजॉन्टल रोज कॉल्ड पीरियड्स, उसकी देन थी. वर्टिकल कॉलम्स कॉल्ड ग्रुप्स. यस, फर्स्ट टाइम ये दोनों टर्म्स भी कॉइन हुए थे. एंड देन द एलिमेंट्स विथ सिमिलर which are similar with respect to their chemical properties are grouped together having atomic weight of nearly the same value. Elements in the same group have the same valency, similar chemical properties. Then based on the periodicity of properties, a number of gaps were left. जहां जहां उसको elements नहीं मिले, उसने gaps भी छोड़े कि ये undiscovered है. Then the properties of undiscovered elements were left vacant gaps. That incorrect atomic weights of some elements were corrected. So उसने contribute किया. So ये सारे contribution are important. सबसे पहले he introduced the term, the rows and the periods, or the groups, the periods and the groups, and then elements which are similar with respect to chemical properties, they were grouped together. Okay, so elements in the same group, they had same valency. ये आज भी होता है. And based on the periodicity of the properties, a number of gaps were left, and properties of undiscovered elements left vacant, and incorrect atomic weights of some of the elements were corrected. Okay, now defects. सबसे बड़ा defect क्या था? He was using atomic weights, and therefore anomalous pairs बन गए. Certain pairs of elements having higher atomic weights were given position before the elements have lower atomic mismatch किया. Okay, so cobalt was placed before nickel. Then the position of rare earths and actinides was not decided. He couldn't justify only if they arranged according to their atomic weights. Then position of isotope. This is very important defect. ऑक्सीजन के आइसोटॉप्स अलग अलग हो गए, कार्बन के आइसोटॉप्स अलग अलग हो गए, क्योंकि his basis of arrangement was atomic weight and not the atomic number, and isotopes had to be placed in same position because of the atomic number. Okay, so इसके defects are very, very important. Anomalous pairs were formed, position of the rare earth and actinides were not correct, and the position of isotopes were incorrect. The isotopes of the same element were placed differently based on their atomic weight. So Moseley, so वो आया, वो बोला सब आप लोगों की सबकी गलती, सबसे बड़ी गलती क्या, एटॉमिक वेट. बताओ एटॉमिक वेट, एटॉमिक वेट के ऊपर हम क्लासिफिकेशन नहीं कर सकते. So he gave the transformation theory that the elements should be arranged on the basis of atomic mass, atomic number. Okay, so most of the defects in the mentalist periodic table disappeared. कैसे? Atomic weights were converted into atomic number. So Moseley arranged elements in increasing order of atomic number. 7 horizontal rows called periods and 18 vertical columns called rows. This forms the basis of the modern periodic table. Atomic number is the basis of the modern table. फिर modern periodic law आ गया. So physical and chemical properties of the elements are periodic function of their atomic numbers. Periodic function of their atomic numbers instead of atomic weight. Hence, the elements, if arranged in increasing order of atomic number, showed similarity in properties after regular interval time. So, if you arrange the elements in the increasing order of atomic number, so the first one and the last one of the same group, that is the lithium के बाद sodium जो आता है, they show similarity in their properties. Okay. So after definite interval of atomic number, reoccurrence of similar electronic configuration takes place. So reoccurrence of similar electronic configuration. Let us look at the group 1, lithium. Lithium, it is atomic number is 3, so 2, 1. Sodium 11, 2, 8, 1. Potassium 2, 8, 8, 1. So they are having the similarity in the property. Each element is having only one electron as the outermost or in the outermost orbit. Okay, so the reoccurrence of same electronic configuration takes place. Since properties of elements are dependent on the number and arrangement of the electrons, including the electrons in the shell, elements having similar electronic configuration have similar properties. Similar electronic configuration will have similar properties. So lithium, sodium, potassium, rubidium, cesium, francium, they all have one electron in their outermost orbit. And so, and the inner and penultimate, so penultimate shell has 8. So this is how he could arrange. So periodic properties, किसको किसको बोलते हैं? So atomic radius, ionization potential, electron. So the properties of elements are dependent on the number and the arrangement of electrons, including the electrons in the valence shell. Elements having similar electronic configuration have similar properties. The periodic properties किसको किसको बोलते हैं? Atomic radius. क्या होता है atomic radius? That is the distance from the center of the nucleus to the outermost shell. Center of the nucleus to outermost shell का जो distance है उसको atomic radius बोलते हैं. उसको nanometer में define करते हैं. Ionization potential, so amount of energy required to remove an electron from the outermost shell of an isolated gaseous atom. सो जितनी एनर्जी आपको लगती है एक एटम को, एक इलेक्ट्रॉन को रिमूव करने के लिए, उसको हम आयनाइजेशन पोटेंशियल बोलते हैं. Then electron affinity, the amount of energy released when an atom in the gaseous state escapes an electron to form an anion. So the amount of energy released when an atom in gaseous state accepts an electron to form an anion. So these are the periodic properties. Atomic radius, ionization potential, electron affinity. Salient features of modern periodic table. So arrangement. So arranges elements in increasing order of atomic number. 7 horizontal rows called periods and 18 vertical columns called groups. Each period begins with an element having one electron in outermost shell and ends with a complete outer electron, outer shell elements. First, and the groups first and 2 are reactive elements, 3 to 14 transition elements, 13 to 17 non-metals in the upper right corner, and 18 onwards noble gas on inorganic gases. So I stop here and I will be asking you the questions from these 3-4 pages forward. Then only I will move forward. Okay. So tomorrow again, 12.